Okay, so as we learned last time how an action potential is generated, now we need to see how it moves from the presynaptic membrane to postsynaptic membrane through a synapse and how it actually activates other neurons. So what happens is that once the action potential is traveling through the membrane, it's creating local circuits that cause it to move towards specific areas of the membrane. In specific areas of the membrane, we have calcium voltage gated channels, which will be activated through the action potential. Once these voltage gated channels open, an influx of calcium ions will diffuse into the presynaptic neuron and make its way into the cytoplasm. Now, these calcium ions aren't usually in the cytoplasm, so they kind of create a little activation of these vesicles. So these calcium ions will activate these vesicles to move towards the presynaptic membrane, fuse with the membrane, and then release the neurotransmitters. The neurotransmitters will be released, and then they will diffuse across the synaptic cleft and into their complementary receptors on the postsynaptic membrane. Once the neurotransmitters are on the postsynaptic membrane, and in this case we're talking about acetylcholine, it will open sodium ion channels, not voltage gated, but regular sodium ion channels, and it will cause these sodium ions to move into the postsynaptic cytoplasm, the cytoplasm of the postsynaptic membrane. So once these ions make their way here, it will cause depolarization through local circuits, and it will cause the action potential to be generated here and then continue down over here. So in order to prevent many action potentials from being generated, what happens is that there's an enzyme here that breaks down acetylcholine into acetate and choline. This enzyme is known as acetylcholine esterase. So it will break it down in order to be recycled again to be made in the presynaptic neuron again.